Hello everyone and welcome back to the video lecture series for Intro Algebra. Today we are going to be covering multiplying and dividing signed numbers, which includes multiplying and dividing whole integers and multiplying and dividing signed rational numbers. So just because we're going to talk about this quite a bit today, factors are two numbers that are being multiplied. So when you multiply two numbers, those are what are called factors of the product. So for example, since 2 times 4 gives you 8, both 2 and 4 are factors of 8. And we're going to be finding factors a lot in this video, specifically finding common factors. So you find factors by using division. So for example, if you did not know the factors of 8, you could find the factors of 8 using division. So you would do 8 divided by 2, and that would give you the whole number 4. So because 8 divided by 2 gave you the whole number 4 with no remainder and nothing after the decimal point, that meant that both 2 and 4 were factors of 8. So you can always find factors by using division. So we're going to get into the rules for multiplying signed numbers, and the general rule with multiplication is that if the two numbers have the same sign, their product is positive. And if the two numbers have different signs, then their product is negative. So in other words, that means if you take a positive number times another positive number, you get a positive number. If you take a negative number and you multiply it by another negative number, you get a positive number. So a negative times a negative is a positive. If the numbers have the same sign, their product is positive. And if you take a positive number and you multiply it by a negative number, or a negative times a positive, it doesn't matter, order doesn't matter here, you will always get a negative product. So if the numbers have different signs, their product is going to be negative. So what we're going to do is, without a calculator, we are going to multiply each of these, keeping in mind the rules for multiplying signed numbers. Also keep in mind, if the two numbers have the same sign, their product is positive. If the two numbers have different signs, their product is negative. So for this first one, for negative 2 times negative 1, we have a negative times a negative. The signs are the same, so the product is going to be a positive 2. For this next one over here on the top right, we have positive 5 times negative 10. We have a positive times a negative. The signs are different, so their product will be negative 50. For this next one, negative 8 times negative 4. If we have a negative times a negative, signs are the same, so their product is positive 32. For this next one, we have negative 5 times positive 2. We have a negative times a positive. The signs are different, so their product is going to be a negative 10. And then remember, order doesn't matter with multiplication, so negative 4 times negative 8, signs are still the same. Their product is still positive 32. And then for this last one, positive 5 times negative 12 is going to give us a negative 60. Also remember that order technically doesn't matter with multiplication, so you can do multiplication in any order that you want, and you can group multiplication however you want. However, if you're looking for any sort of suggestions, you can always just multiply in the order that you see the numbers appear when you read the problem from left to right. So for the first one, we have positive 8 times negative 2 times negative 3. You can multiply these in any grouping or order that you want because order does not matter with multiplication. However, if you want to, you can always just multiply from left to right. So starting with positive 8 times negative 2, we have a positive times a negative. The signs are different, so their product is going to be a negative 16. Then we're going to take negative 16 and multiply it by negative 3. So first of all, a negative times a negative is a positive. 16 times 3 is 48. And you'll find that if you had grouped negative 2 times negative 3 together and then multiplied it by 8, you would have still gotten 48. So order doesn't matter with multiplication. So we're going to do the same thing for this next one. Remember, if at any point in this video you want to try a problem before I do it, just feel free to pause the video and then resume when you are done working. So for the next one, I'm going to multiply in the order that I see from left to right, and I'm going to multiply 2 at a time. So I'm going to take negative 2 times positive 3 first. I have a negative times a positive. The signs are different, so their product will be a negative 6. Then continuing to work from left to right, I'm going to do -6 times -1 next. -6 times -1. Negative times a negative is a +6. Then I'm going to multiply that +6 by -4. So a positive times a negative is a negative. 6 times 4 is 24. So -24 is going to be your final answer. And then for the last one, I'm going to multiply from left to right, starting with -3 times +4. So -3 times +4, we have a negative times a positive. Signs are different, so their product is -12. Then I'm going to take -12 and I'm going to multiply it by -5. So a negative times a negative is going to be a +60. So if you guys had noticed when we did these last few problems, when you have more than two numbers that are being multiplied, if you had noticed, back over on this first one and this last one, in the first one and this last one, we had an even number of negatives. In this first one, there were 2 negatives, and in this last one, there were also 2 negatives. So an even number of negatives is always going to come out to a positive product. So the product of an even number of negatives is always positive. Now, on the flip side, for this middle one here, we had 3 negatives. We had an odd number of negatives, and our final product was a negative number. So the product of an odd number of negatives is negative. So product of an even number of negatives is positive. The product of an odd number of negatives is negative. Now you're going to notice that the rules for dividing sign numbers are the exact same as the rules for multiplying sign numbers. So the general rule for division is if the numbers have the same sign, their quotient is going to be positive. If the numbers have different signs, then their quotient is going to be negative. So if you take a positive number and divide it by another positive number, you get a positive number. If you take a negative number and divide it by another negative number, you get a positive number. So a negative divided by a negative is a positive. If the signs are the same, their quotient is positive. And then if the signs are different, their quotient is negative. So a positive divided by a negative is a negative, and a negative divided by a positive is also a negative. This is why it technically doesn't matter where a negative sign is on a fraction, because if a negative is present somewhere in the fraction, the entire quotient is going to be negative because of this last rule right here. So if you had -1 over 2 is the same as 1 over -2, which in either case will give you -1/2. So that's why it technically doesn't matter where the negative is on a fraction, because if the signs are different, their quotient is always negative. If a negative appears on a fraction somewhere, the entire fraction is going to be negative. And you'll also notice that these are the exact same rules as multiplying sign numbers. So we're going to evaluate each of these without a calculator. So starting with -16 divided by -8, if the signs are the same, their quotient is going to be positive. So a negative divided by a negative is a +2. So then for -24 divided by -2, if the signs are the same, their quotient is positive. So -24 divided by -2, negative divided by negative is a +12. Now remember, you can either write division with the division symbol or in what is called fractional form. You can always read fractions as division. First thing I noticed with this next one is that we have a double negative. Remember, a negative times a negative is always a positive. So that will turn into 56 over 7. You can also think of this as 56 divided by 7. 56 divided by 7 is 8. So then for the next one, you can either think of this as -12 over 3, or you can think of this as -12 divided by 3. In either case, a negative divided by a positive, if the signs are different, their quotient is negative. So a negative divided by a positive is a -4. So then for the next one, for -8 divided by -1, if we have a negative divided by a negative, that is going to be a +8. Anything divided by 1 is itself. And then for the last one, you can think of this as 45 divided by -5. If the signs are different, their quotient is negative. So positive divided by a negative is a -9. So those are some of the basics for multiplying and dividing positives and negatives. And you always need to keep those rules in the back of your mind even when you are multiplying or dividing fractions. Because if one of your fractions is negative or both of your fractions are negative, you need to remember the rules for multiplying and dividing positives and negatives. Now, with multiplying fractions, this is actually easier than adding or subtracting fractions because you do not need a common denominator when you multiply fractions. So all of that we did in the last video with the lowest common denominator, you don't need to do that here. So you do not need a common denominator when multiplying fractions. All you have to do is multiply the two numerators and multiply the two denominators. The hard part is the reducing. So you have two options. You can either just do the multiplication right away, multiply the numerators, multiply the denominators, and then do some reducing at the end. I will caution you away from this, especially if your numerators and denominators are larger numbers. That will give you a fraction with a really large numerator and a really large denominator. And without a calculator, you would have to find the greatest common factor between the top and the bottom and reduce it. So I will say that reducing at the end is basically the hard way of doing this. There is an easier method of reducing that is called cross-reducing. And I want to point out that cross-reducing only works when multiplying. Cross-reducing absolutely does not work when you add or subtract. It sort of works with division. We'll get to that in a little bit. But cross-reducing really only works when multiplying. Do not cross-reduce when adding or subtracting, and do not cross-reduce with division. But if you see a multiplication symbol between your fractions, you can do a process called cross-reducing. And I think the easiest way to explain what cross-reducing is to actually do an example. But in general, cross-reducing is a method of reducing that you can do at the beginning of the problem. And if you fully cross-reduce and do all of the reducing possible at the beginning of the problem, you will not have to do any reducing at the end. After you do all of the cross-reducing, when you multiply the numerators and multiply the denominators, your final answer will already be in lowest terms. So I highly recommend this method because you'll be working with smaller and easier numbers. The key is, remember, order does not matter with multiplication. And because order does not matter with multiplication and you don't need common denominators, what cross-reducing is essentially asking is you're going to look at all of the numbers on the top and see if any of the numbers in the numerators have any common factors with any of the numbers in the denominators. So we're going to multiply each of these without a calculator. So we're going to start with 7/8 times 9/10. So let's take a look at the two numbers on the top. We have 7 and 9. Do either 7 or 9 have any common factors with the numbers on the bottom, 8 or 10? And yes, you can go between fractions as well. Because you're just going to multiply the tops and multiply the bottoms, you're looking for if any of the numbers on the top have any common factors with any of the numbers on the bottom, which unfortunately they don't. The only factors of 7 are 1 and 7, and neither of those go into 8 or 10. 9 doesn't go into 8 or 10, and the only factor of 9 is 3, which also does not go into 8 or 10. So there is no cross-reducing to do here. Because there's no cross-reducing to do here, that means when you multiply the tops and multiply the bottoms, your answer will be in lowest terms. So 7 times 9 is 63, over 8 times 10 is 80. And because there was no cross-reducing to do at the beginning, there is no reducing to do at the end. 63 and 80 have no common factors other than 1. Now for this next one, we're going to ignore the negative for a moment, and we're just going to focus on the numbers that we have. So let's take the numbers on the tops, 3 and 10. And then we'll look at the numbers on the bottom, 4 and 21. Do any of the numbers on the tops have any common factors with the numbers on the bottom, even if they're in different fractions? Which, yes, 4 and 10 have a common factor. They're both even numbers, so they're both divisible by 2. And it doesn't matter that they're in different fractions, because remember, when you're multiplying fractions, you're just going to multiply the tops and multiply the bottoms anyway. So since 4 and 10 have a common factor, I'm going to go ahead and take 4 and 10, and I'm going to divide them both by that common factor 2. As long as you do the same thing on the top and the bottom, you can do this. So 4 divided by 2 gives you 2, and then 10 divided by 2 gives you 5. And again, we're going to ignore the negative for a moment. Now, let's take a look at the numbers on the top, 3 and 5 now, and the numbers on the bottom, 2 and 21. Do any of the numbers on the top have any common factors with the numbers on the bottom? Yes, 3 and 21 have a common factor of 3. So since we still have some common factors, I'm going to keep going through the cross-reducing process. So 3 divided by 3 is 1, and 21 divided by 3 is 7. And now let's just double check to see if any of the numbers that are left over have any common factors. So we have 1 and 5 on the top and 2 and 7 on the bottom. So there's no more common factors since these are all prime numbers, so we are ready to multiply. Now here is where that negative comes into play. So a negative times a positive is a negative. And then let's multiply the new numbers on top. 1 times 5 is 5. Over 2 times 7 is 14. And because we went through the process of fully cross-reducing as much as possible at the beginning, we do not have to do any cross-reducing at the end, so negative 5 over 14 is our final answer. So then for this next one, for negative 4 over 9 times negative 5 over 8, we're going to do the same thing. I'm going to ignore the negatives for now, and I'm just going to focus on the reducing part. So let's take a look at the numbers on the top, 4 and 5, and then the numbers on the bottom, 9 and 8. Do any of the numbers on the top have any common factors with the numbers on the bottom? Yes, 4 and 8 have a couple of different common factors. And I will say that you're going to save yourself a lot of time and work if you pick the largest common factor. So yes, 2 goes into both 4 and 8, but what is a larger number that goes into both 4 and 8? So the larger number that goes into both 4 and 8 is 4, so 4 is the greatest common factor. So I'm going to take both 4 and 8, and I'm going to divide them both by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So let's take a look at the numbers that we have left over. We have 1 and 5 on the top and 9 and 2 on the bottom. So do any of the numbers on the top have any common factors with the numbers on the bottom? No, they don't. So because they don't, we have finished cross-reducing and we are ready to multiply. Now is where we need to pay attention to the negative. So we have a negative times a negative. A negative times a negative is a positive. So now let's multiply the tops. 1 times 5 is 5. And then on the bottom, 9 times 2 is 18. And then because we went to the trouble of doing the cross-reducing at the beginning, we do not have to do any reducing at the end. 5 over 18 is our final answer. So then for the next one, remember, if you have, order doesn't matter with multiplication, and you can group multiplication however you want. So when you have 3 fractions being multiplied, you can still cross-reduce because you're just going to see if any of the numbers on the top have any common factors with any of the numbers on the bottom. Now, I will say one thing that you should look for is if any of the numbers on the top are the exact same as the numbers on the bottom. I'm looking at 9 and 9 here. So there's a 9 on the top right here and a 9 on the bottom right here. When you have the same number on both the top and bottom, the greatest common factor between 9 and 9 is 9. And remember, anything divided by itself is 1. So 9 divided by 9 is 1, and 9 divided by 9 is 1. So when you have the same number on both the top and the bottom, you can just cancel them out and they don't go away, they become 1. So let's look at the remaining numbers and see if any of those have any common factors with any of the numbers on the bottom. So I'm taking a look here at 6 and 8. What number goes into both 6 and 8? 2. So because there is a common factor of 2, I'm going to take 6 and 8, and I'm going to divide them both by 2. So 6 divided by 2 is 3, 8 divided by 2 is 4. So let's take a look at the leftover numbers on the top. We have 1, 3, and 7, and the numbers on the bottom, 4, 5, and 1. So do any of the numbers on the top have any common factors with the numbers on the bottom? They don't. So because of that, we're ready to just multiply all of the numerators and all of the denominators. So in the numerators, well, they're all positive, so we don't have to worry about that. 1 times 3 is 3. 3 times 7 is 21. And then on the bottom, 4 times 5 is 20. 20 times 1 is 20. And because we went to the trouble of fully cross-reducing at the beginning, we do not have to do any reducing at the end. 21 over 20 is now our final answer. So I want you guys to give it a try for these two. So I want you guys to, remember, cross-reduce at the beginning and then worry about your negatives when you're ready to multiply. So I want you guys to pause the video, try these two, and then resume the video when you are done and ready to check your answer. Okay, so for this first one, I'm going to ignore the negatives for just a moment. Remember, this can also be, used as an alternative for the multiplying dot. So this is negative 3 over 8 times negative 12 over 7. All right, so let's just ignore the negatives for a second and look at the numbers on the top and the numbers on the bottom. So on the top we have 3 and 12, and on the bottom we have 8 and 7. First, I want to point out that it doesn't matter if 3 and 12 have a common factor. That doesn't count because both 3 and 12 are both on the top. You're looking for if any of the numbers in the numerator have common factors with any of the numbers in the denominator. I'm looking at 12 and 8. Now, there's a couple of different common factors, and you're going to save yourself a lot of headache if you choose the largest one. So what is the largest number that goes into both 12 and 8? That is 4. So I'm going to take 12 and 8 and divide them both by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So let's take the numbers on the top, 3 and 3, and the numbers on the bottom, 2 and 7. It doesn't look like any of the numbers on the top have any common factors with the numbers on the bottom. So now let's start to pay attention to our negatives. So we have a negative times a negative. A negative times a negative will give you a positive. So then 3 times 3 is 9. And then on the bottom, 2 times 7 is 14. Then for the next one, again, it doesn't matter if you have 3 fractions being multiplied. You can still cross-reduce here. I'm going to ignore the negative for just a moment, and I'm going to see if any of the numbers on the top have any common factors with any of the numbers on the bottom. And there's a lot of them. Now, you could have easily identified 4 and 10 to have a common factor, or 4 and 18 to have a common factor. And it really doesn't matter what you did. So you might actually find that depending on the choice that you made there, your work might look slightly different than mine, but as long as you get the same final answer and the same fully reduced final answer, you've done it correctly. Because you're going to find in this class there are going to be some times when you can do a problem in a slightly different way and still get the same answer because you still did it correctly. So just keep that in mind. However, I am looking at the fact that 5 and 10 have a common factor. They have a common factor of 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. I'm also looking at 3 and 9. So 3 and 9 have a common factor of 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. I also see that 4 and 18 also have a common factor of 2. So 4 divided by 2 is 2, and then 18 divided by 2 is 9. Now, before you start multiplying and calling it good, take a look at the numbers that are left over and see if any of the numbers on the top have any common factors with the numbers on the bottom, and if any of the numbers on the top are the same as the numbers on the bottom. I'm looking at 2 and 2 here. This indicates that we still have more cross-reducing to do. So 2 and 2, anything divided by itself is 1, so 2 divided by 2 is 1, 2 divided by 2 is 1. So now that most of the things that are left over on the top are 1s, and we're pretty much done. Now we're going to take a look at our negatives and positives. So we have a positive times a negative. So positive times a positive will give us a positive. Positive times a negative will give us a negative. So our final answer is going to be negative. So let's multiply the numbers on the top. 1 times 1 times 1 is 1. And then on the bottom, 3 times 1 is 3. 3 times 9 is 27. So negative 1 over 27 is going to be our final answer. Now for dividing fractions, remember, cross-reducing only works with multiplication. I said you can sort of do it with division. Now, once again, with dividing fractions, you do not need common denominators. So don't bother finding common denominators when you're dividing fractions. You don't need it. So here are the steps to dividing fractions. You're going to change the divisor, which is the second part of the division problem, to its reciprocal. Reciprocal means flipping it over. So a reciprocal of a fraction is just flipped over, switching the top number and the bottom number. So basically what you're going to do is you're going to flip the second fraction. Then you're going to change the division sign to multiplication, and you're going to multiply the resulting fractions. And then you're going to reduce if needed. Now here's the thing. You're going to eventually change the division sign to multiplication. As soon as you change the division to multiplication, you can cross-reduce because cross-reducing works with multiplication. The key is you cannot cross-reduce until you change the division sign to multiplication. As soon as you change that division sign to multiplication, you can start cross-reducing. So the process for dividing fractions can really be boiled down to 3 words. Keep, change, flip. You're going to keep the first fraction as it is. Don't do anything with it. You're going to change the division to multiplication. And then you're going to flip the second fraction. And then as soon as you change the division to multiplication, you can start cross-reducing because you now have a multiplication problem. So without a calculator, we are going to be dividing each of these. So starting with 4/5 divided by 3 over 10. Remember, do not cross-reduce until you have changed the division sign to multiplication. So I know it is extremely tempting that 4 and 10 have a common factor. Don't touch any of them. Don't start reducing because you can't cross-reduce with division. You can only cross-reduce with multiplication. So let's get the keep, change, flip out of the way first, and then we'll deal with the multiplication problem that results. So we're going to keep the first fraction as it is. So we're going to leave 4 over 5 alone. Then we're going to change the division to multiplication. And then we are going to flip the second fraction. So when you flip 3 over 10, you get 10 over 3. So then let's take a look if any of the numbers on the top have any common factors with the numbers on the bottom. So do either 4 or 10 have a common factor with 5 or 3? 5 and 10 have a common factor. So 5 divided by 5 is 1. 10 divided by 5 is 2. And that was pretty much it. So let's multiply the tops. 4 times 2 is 8. And then divided by 1 times 3 is 3. And remember, because you cross-reduced at the beginning, you do not need to cross-reduce at the end. So then for the next one, I'm going to do the keep, change, flip, and I'm just going to leave the negative alone. So I am going to keep keep the first fraction as it is, including the negative sign. So I'm going to keep negative 3 over 4. I'm going to change the division to multiplication, and then I am going to flip the second fraction. So if we flip over 1 over 8, we get 8 over 1. Then I'm going to ignore the negative for a moment, and I'm going to work on cross-reducing, because now that I've changed the division to multiplication, I can cross-reduce. So just ignoring the negative, let's see if any of the numbers on the top have any common factors with any of the numbers on the bottom. Looks like 4 and 8 have a common factor, and the greatest common factor between 4 and 8 is 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And that does look like it, since the numbers on the bottom are now 1. Looks like we're going to be pretty much done. So now let's pay attention to our negatives. So we have a negative times a positive is a negative. 3 times 2 is 6. Over 1 times 1 is 1. And remember, anything divided by 1 is itself. So negative 6 divided by 1 is just negative 6. So negative 6 is going to be our final answer. So when you have a 1 in the denominator, you can just basically get rid of it, because anything divided by 1 is just itself. Now on the flip side, you can also do that backwards. You can instantly turn any whole number into a fraction by putting it over 1. So that's exactly what I'm going to do for this next one here, for this negative 4/7 divided by negative 20. I am going to instantly turn negative 20 into a fraction by putting it over 1. So now that both of these are fractions, now I can do the keep, change, flip. So I am going to keep the first fraction as it is, including the negative sign. I am going to change the division to multiplication. And then I am going to flip the second fraction. Now remember, with negatives on fractions, it doesn't really matter where the negative goes. If the negative is in the fraction somewhere, the whole thing counts as negative. So I'm just going to put the negative in the middle, and then when I flip 20 over 1, I get 1 over 20. Then I'm going to ignore the negatives for just a moment, and then I'm going to see if any of the numbers on the top have any common factors with the numbers on the bottom. So 4 and 20 have a common factor. They're both even, so they have a common factor of 2. But you should really save yourself some agony and find the greatest common factor. So the largest number that goes into both 4 and 20 is 4. So 4 divided by 4 is going to give me 1. 20 divided by 4 will give me 5. Then, since the numbers that are on the top are now 1, now we're ready to multiply. So now let's pay attention to our negatives. So we have a negative times a negative. A negative times a negative will give us a positive. And then let's multiply what's left over. So 1 times 1 is 1. 7 times 5 is 35. So positive 1 over 35 is going to be your final answer. So that's going to be the same idea for this next one. We are going to instantly turn the number 5 into a fraction by putting it over 1. So now that both of these are expressed as fractions, now we can do the keep, change, flip to divide the two fractions. So we are going to keep the first fraction as it is, 5 over 1. We're going to change the division to multiplication. And then we are going to flip the second fraction. So when you flip 5 over 8, you get 8 over 5. Since these are both positive, our answer is going to be positive, but let's just cross-reduce. Do any of the numbers on the top have any common factors with the numbers on the bottom? And are any of the numbers on the top the same as the numbers on the bottom? I'm looking at this 5 on the top here and this 5 on the bottom here. Anything divided by itself is 1. So 5 divided by 5 is 1. 8 divided by 5 is 1. Sorry, 5 divided by 5 is 1. So then, let's multiply what's left over. 1 times 8 is 8. 1 times 1 is 1. 8 divided by 1 gives you 8. So I want you guys to try your hand at it for these next two if you haven't tried any of these already. So I want you guys to divide each of these without a calculator and pause the video and then resume when you are done working and ready to check your answer. Okay, so looking at the first one, we're going to first keep the first fraction as it is, 3 over 10. I'm going to change the division to multiplication, and I'm just going to leave the negative in the middle because remember, it doesn't matter where it goes. I'm just going to leave it in the middle, and then I am going to flip the second fraction. So when we flip over 18 over 25, we get 25 over 18. And I'm going to ignore the negative for a moment, and then I'm going to do some cross-reducing. So let's see if any of the numbers on the top have any common factors with any of the numbers on the bottom. And they do. I'm looking at 3 and 18 to start. 3 and 18 have a common factor of 3. So 3 divided by 3 is 1. 18 divided by 3 is 6. 10 and 25 also have a common factor. They're both divisible by 5. So 10 divided by 5 is 2, and then 25 divided by 5 is 5. So let's take a look at the numbers that are left over on the tops, 1 and 5, and the numbers on the bottom, 2 and 6. It doesn't look like any of the new numbers on the top have any common factors with the new numbers on the bottom, so that means that we are ready to multiply. Now we get to pay attention to our negative. So a positive times a negative is a negative. And then let's multiply the tops. 1 times 5 is 5. Over 2 times 6 is 12. And since we cross-reduced at the beginning, we don't need to reduce at the end. Negative 5 over 12 is our final answer. So then looking at the next one, both of these numbers are positive, so we don't have to worry about any negatives here. So let's do the keep, change, flip to start. So we're going to keep 2 over 5. We're going to change the division to multiplication, and then we're going to flip 3 over 4 to give us 4 over 3. Then we're going to see if any of the numbers on the top have any common factors with the numbers on the bottom. So the numbers on the top are 2 and 4. And remember, I don't care if these two have a common factor. They're both numerators, so they don't count. Do 2 or 4 have common factors with either 5 or 3? They don't, unfortunately, so there's no cross-reducing to do here, which means there will be no reducing to do at the end. So all we're going to do is multiply the tops. 2 times 4 is 8. Over 5 times 3 is 15. So 8 over 15 will be your final answer. Now, a closely related concept to fractions and decimals is also percents. We're going to cover percents a lot more extensively later in the course, but we're going to introduce percents now because they are going to come up, and they sort of already have a couple videos ago. So what a percent means is divided by 100. A percent means part out of 100. And you actually encounter percents all the time, probably every day. So you can take a percentage off, such as in a sale, 50% to 75% off means you're taking a percentage or a portion of the original price away from it. You can use percents to do what's called partitioning, which is to split things up. So 15% of a town's budget could go to trash pickup. And you can also use percentages in, approval ratings. Approval percentage of those who approve versus the percentage of those who don't approve. So percents are used in a variety of contexts, in a lot of contexts in everyday life. Now remember, percents are parts of 100. So what I have illustrated here are 100 squares. There's 100 squares here. And out of those 100 squares, 50 of them are shaded. So this is a visual representation of 50%, which means 50 parts out of 100 parts are shaded. Now you can also represent this as a fraction. You can represent this as 50 shaded squares divided by 100 total squares, since a fraction is a part out of a whole. 50 over 100 can also reduce to 1/2. So you could also say that 1/2 of this overall total square is shaded. Now, even further than that, what is 1/2 as a decimal? 1/2 as a decimal is 0.5. So you could also say that 0.5 of this square is shaded. So this means that percents, fractions, and decimals are three completely different ways to represent the same part out of a whole relationship. You can represent this part out of the whole relationship that is demonstrated here as either 50%, 1/2, or 0.5. All of these mean the exact same thing. These are all the same. They all represent the same part to whole relationship, but they're just written in three different ways: a percent, a fraction, and a decimal. So what that means is that you can convert between percent, fraction, and decimal, because remember, they're just different ways of writing a number. It doesn't actually change the quantity. So percents can always be written as fractions or decimals. So for example, if you say 50% off all boots, you might also advertise all boots are half off. Those mean the exact same thing. You're taking 50% or half of the original price. So we're going to do a bunch of conversions, and most of these are really easy to do without a calculator. We're going to be changing a percent to a fraction. We're going to be changing a percent to a decimal. We're going to be changing a decimal to a percent and changing a fraction into a percent. And each of these are going to have their different uses, and we're going to explore a lot more of them later, though we'll do a couple here. Now remember, each of these conversions just change the way the quantity is written. They do not change the quantity itself. It's just changed the way it appears, not the actual quantity. So first thing, to change a percent to a fraction. First thing you do is you drop the percent sign, and then you're going to place the number over 100. So basically you'll drop the percent sign, turn it into a numerator, and give it a denominator of 100. And then if you can or have to, you're going to simplify or reduce the resulting fraction if possible or necessary. So we're going to change each of these percents into fractions, and we're not going to use a calculator here. So to change 7% into a fraction, I'm going to drop the percent sign and put it over 100. And then I'm just going to see if I can reduce this. 7's a prime number, and 7 doesn't go into 100, so this is fully reduced. So 7 over 100 is 7% written as a fraction. Now for the next one, 150%, let's change this into a fraction by first dropping the percent sign and then placing the number over 100. The hard part here is going to be reducing. Now, here's a trick that you can always do when you're reducing fractions. If both of the numbers, if both the numerator and the denominator end in a 0, that means they're both divisible by 10. So what we can do here is we can cancel out 1 0 on the top and 1 0 on the bottom. What that is basically doing is dividing both the top and the bottom by 10. And you can do this as long as both the numerator and the denominator end in a 0. So that reduces it to 15 over 10, which helps. We're not fully reduced yet because there is a common factor between 15 and 10. 15 and 10 are both divisible by 5. So I'm going to go ahead and divide both the top and the bottom by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. 3 and 2 are both prime numbers, so this is now fully reduced. So fully reduced, 150% written as a fraction is 3/2. Now, to change a percent to a decimal is actually even easier. So to change a percent into a decimal, we're going to drop the percent sign, and then you are going to divide the number by 100. And you can very easily divide the number by 100 without a calculator. So to divide a number by 100 without a calculator, all you have to do is move the decimal point to the left 2 places. Because remember, tenths, hundredths, second decimal place is 100. So you just have to move the decimal point to the left 2 places to divide by 100. So we're going to change each of these percents into decimals, and we don't need a calculator for this. So for 42%, the first thing I'm going to do is I'm going to drop the percent sign. Then I'm going to locate the decimal point. And if there is no decimal point, remember you can insert a decimal point on the right end of a number. So since there wasn't already a decimal point, I'm going to put a decimal point right here. Then I'm going to divide the number by 100 by moving the decimal point to the left 2 places. So I'm going to move it to the left 1 place and then to the left 2 places. And I'm going to, it lands right here. So as a decimal, 42% is 0.42. So then for the next one, for 1%, first thing I'm going to do is I am going to drop the percent sign. Then I'm going to locate the decimal point, and if there is no decimal point, I'm going to put a decimal point on the right end of the number. And then I'm going to divide this by 100 by moving the decimal point to the left 2 places. So I'm going to move it to the left 2 places. So my decimal point has landed here, and in this gap I am going to insert a 0. So this turns into 0.01. You technically don't need the 0, that comes before the decimal point. Doesn't hurt though. So as a decimal, 1% is 0.01. So then we're going to do the same thing for the next one. Yes, you can have a part of a percent. Yes, you can have 37.5%. So just imagine those 100 squares again. 37 and 1/2 of those are shaded. So you got 37 whole squares that are shaded, and then half of a 38th square is shaded. So we have 37.5 shaded squares out of a total of 100 squares. All right, so to turn this into a decimal, I am going to drop the percent sign. And then I already have a decimal point, so I'm going to use it. So I'm going to use my existing decimal point, and I'm going to divide this number by 100 by moving the decimal point to the left 2 places. So I'm going to move it to the left 2 places. So I have landed right here. So 37.5% as a decimal is 0.375. You can go ahead and keep all those digits after the decimal point unless the problem tells you to round. Here's an application of that. So let's say that a bank gives 0.1% interest on savings account. And we're going to represent this interest rate as a decimal. And you might be thinking, oh, it's already a decimal. No, it's technically a percent. 0.1% means out of those 100 squares, 1/10 of one of them is shaded. It's a really tiny percent. This is a really, really tiny part out of 100. So technically, this isn't a percent, even though it has a decimal point in it. So to turn 0.1% into a decimal, I am going to drop the percent sign. And then I am going to divide the number by 100 by taking the existing decimal point and moving it to the left 2 places. So I'm going to move this to the left 2 places. My decimal point has landed here. And then in that gap, I am going to put a 0. So as a decimal, 0.1% is 0.001. It's a really, really tiny decimal. Now to go the other way, to turn a decimal into a percent, what we're going to do is we're going to multiply that decimal by 100 and then insert a percent sign. So the easiest way to multiply by 100 is to do that exact same process you just did backwards. So a really easy way to multiply by 100 without a calculator is to move the decimal point to the right 2 places. So we're going to change each of these decimals into percents, and we're not going to use a calculator. So to turn 0.425 into a decimal, I'm going to first multiply it by 100. To multiply it by 100, I'm going to take my existing decimal point and I am going to move it to the right 2 places. So I'm going to move it to the right 1, 2 places. I have landed here between 2 and 5. So 0.425 as a percent is 42.5%. Now to turn 0.3 into a percent, I'm going to first multiply by 100. To multiply by 100 without a calculator, I'm going to move the decimal point to the right 2 places. So I'm going to move this decimal point to the right 1, 2 places, and I have landed right here to give me 3%. Since the decimal point was on the right end of that number, it is the whole number 3, so this is 3%. Then to turn 0.15 into a percent, I am going to first move the decimal point to the right 2 places to multiply by 100. So I'm going to take that decimal point and I'm going to move it to the right 1, 2 places. I have landed right here after the 5, and since there's nothing that comes after the decimal point, this is the whole number 15%. Now, technically, whole numbers count as decimals, and unless you see a percent sign with it, it's technically a decimal. So 2 is technically the decimal form of some other percent. So I don't see a decimal point, which means that I can insert one right here on the right end of the number. So I'm going to multiply 2 by 100, which you can do. 2 times 100 is 200. Or move the decimal point to the right 2 places. It doesn't matter. 2 times 100 is 200%. And then for the last one, to change a fraction to a percent. This one's a little bit more involved, and this one you do need a calculator for, especially for some of the harder ones. So yes, we will be using a calculator for this next problem. So to change a fraction into a percent, you have to go in stages. You first have to turn the fraction into a decimal and then turn the decimal into a percent. So you have to go in pieces, change the fraction to a decimal, then change the decimal to a percent. So the first thing you do to turn the fraction into a percent, you're going to divide the numerator by the denominator. So you're going to take the number on the top and divide it by the number on the bottom, and you can go ahead and use a calculator. And then you're going to multiply that decimal by 100 and insert a percent sign to turn it into a percent. So this is an application. I actually do these kind of conversions all the time when I calculate any of your grades, any of your test grades, back when this class met in person. So let's say out of a possible 50 questions, a student gets 46 correct. So the score represented as a fraction would be 46 out of 50, and that is the initial score that you see either on any homework problems or any exam questions, be they in-person exams or even your My Math Lab exams. The score is going to be first represented as a fraction. Then that fraction is going to be turned into a percent grade. So to turn 46 out of 50 into a percent grade, the first thing we're going to do is we're going to convert it to a decimal. So on a calculator, I'm going to do 46 divided by 50, which gives us 0.92. Then you're going to turn 0.92 into a percent by multiplying it by 100. And you can either do that on the calculator or just quickly move the decimal point to the right 2 places. And then that gives a score of 92%. So that is how grades that are represented as fractions, as number correct divided by total, are turned into percent grades. So that is it for section 7.5 and 7.6, which is multiplying and dividing integers and signed rational numbers, and a little bit with fractions, decimals, and percents. So thank you all very much for watching. And when we start, and in the next video, we're going to start doing some more algebra heavy concepts when we get into properties of, some various algebraic properties, and finally, order of operations. So stay tuned for that. Thank you all very much for watching, and I will see you guys in the next video. Bye-bye.